Okay, good morning everybody. So I can guarantee I will exceed my time slot, so don't be afraid. I will tell you something about the relationship between software, standards and training. So why do we speak about these kind of things? The background is that up to the year 70s, it was just enough to heat up our buildings somehow. And now we pretend comfort without using so much energy. So you have the progression with time, and of course this means that installation and more complicated, and calculation standard also has to follow, and then you have to regulate somehow these kind of things. So software calculation tools are needed, of course. You cannot continue with this old calculator that somebody still remembers, okay? Why professional calculation tools? Because we have two tasks. The so-called designer first have to size, so to assemble some pieces together and decide the size of each piece. And the second task is, well, you have also to check how all these kind of things you put together will behave in an average year, because we have also energy performance requirements. And to do this, of course, you know to describe the building. So something like a graphic input to describe your building. You need data about components, so maybe some database, because there are so many products nowadays. You need to perform the calculation. You've seen the algorithm behind that is very complex, so you cannot remember everything. And then you have to present results and give feedback, so a graphical presentation of the results. And then you might have integrated check about compliance, depending on your regulation, and maybe compile a standardized report, because many countries ask for an XML at the end to check, to have a trace, a record of your design to see if it complies. So all these tasks require software. And of course the tools, this very quickly. In the past we had just a handheld calculator, and of course this is totally flexible, but it's a no help with databases and all these kind of things. It's just for rule of thumbs, calculation, rough sizing, and maybe screening for mistakes, some calculation by an expert. Then you have the experimental tool, which is an Excel sheet. You have seen an example. This is very good, for example, for training, for doing the calculation the first time yourself, so that you understand very well. It has a very low, unfortunately, the interface capability is not so high. You may have some small database as well, but of course, if you have to calculate a complex building, take into account regulation, all kinds of things, it's not enough. But you can customize it. So you have this typical application. Standards development, software validation, could be also another use of Excel, because you need to validate software. So to build up a very traceable reference case, this is, I think, the optimal tool for this kind of issues. Of course, professional use means quick calculation, and this is not the case for Excel for such a complex calculation, of course. So, and we have professional tools, application software. Of course, we have well-developed interface, we have integrated database, it's a fast calculation. You do not need to be an expert about modeling. Declared algorithms, sometimes we have to check. Some countries ask for a validation of software. That's the role of the modular structure of the Excels behind, and cannot be customized if it's not complex enough. And typical application is professional productive use and energy performance calculation. And of course, we will see, to develop such a software, you need a market. And if you need a market, you need to have adopted some standards, and based on this standard, you will develop the software. And then you have simulation tool, which is typically a research tool. You see Energy Plus, Transys, and all these kind of things. But here, of course, is a general purpose scientific tool. The interface, the basic interface is just text, and you have to build something around. Little traceability is another point for regulation use, because you have a lot of black boxes. It's not linked to databases. All these kind of things that you have to build around is like building a professional software. You just have some calculation core inside, which is provided by somebody else, but of course it is rather black box and not fully traceable. So typical application, I think, is research or design of specific comfort solution, where you can use such a tool sometimes. Okay. EPB standards were designed thinking about these kind of things, because the objective software-proof modules, for example, demonstration Excel. Every standard should have a demonstration Excel. And testing link between modules, because you have to put together all modules. This is not trivial. And so we have a software tool, and now we are able also to process several modules together. You've seen an example before of the storage and the solar system. Application software validation is also another application, and connected with databases. So the type of input data have been classified so that it's quite easy to know which is the data coming from the manufacturer or something else. So without professional software, no chance to mass production of design, compliance check, and this kind of design. So it's a big investment to do, because to have a professional software for energy performance calculation, it costs some millions euros typically if you're building from scratch. So of course, if you do not have a market behind, no chance, except for simple tools, of course, which are not much. And what are these existing? This is probably coming in Italy, for example, where we are on the way of adopting most of the EPB standards. For example, this is an example from a software using already EN52016 on an hourly basis. So you can see the result here. This is the power required, and you see that you have needs both on heating and cooling. And this is the temperature in your building, and you see the dynamics all around the year. So something already exists that is using exactly EN52016. As well as, for example, and what I mean by interfaces, for example, this is an example of a feedback that a software can give you, because you have tables, of course, when you have use profiles. If you see on a weekly basis, you see, for example, the difference the weekend. For example, this is occupation. It's easier to see this when you have an interface presenting this also in a graphical way, just to understand what is really your input. And for example, also, this software already has technical system configuration. You can decide if for each service, if it is centralized or autonomous, so you have all the combination, and then you can give the details, for example, for the ventilation, which are the features that are included in your ventilation system. So you can just combine your system, define your system, and the algorithm will be adapted to this. And this is another great help by the software. And for example, also it uses also, for example, calculation of operating condition according to the 15316.1. First, you define how you are controlling your emitters, which is the type of circuits, which is the type of control. You take into account how your generator is connected to the network. This also can make a difference, because you need flow or return temperature depending if it's a boiler, or a condensing boiler, or a heat pump. And the result, you have your temperatures along your installation depending on the season. So you take really into account operating condition. This is a feature, for example, which is inside EPB standards. So please remember, calculation tools are just big calculators. So who uses a calculation tool shall always be in control, knowing what's happening. And this has two requirements. So who is using a software shall be knowledgeable, so trained, and the calculation tool shall show what's going on, not just the last figure at the end of the calculation. So, and you don't understand what happens in the middle. And for an example of clear interface, this is an example of a graphic interface. You just go around on your plans that you can draw on your plan. But if you just have the 2D input, it's not very practical. You don't know what you're doing. And so it creates automatically the 3D. And for example, if you see here, you have a terrace, and you can exactly, here you give a number, and here automatically it will move, so you know what you're doing really. Otherwise, in 2D, you may not be very aware of what's going on. So this is how software can help you very much to define correctly your building, and in an easy way. So here your example is Google Maps, and so you can check orientation and neighboring buildings, all these kind of things. So it can be very practical. Databases, of course, database of materials, or just selecting your boiler in a list. That's very, of course, helpful. Or giving you not only the last figure, but a whole bunch of information like temperatures, like what's going on in the, this is an example with a monthly what's going on month by month, where are the losses, and for example the solar system, which is the part covered month by month as well. And be aware that you must keep in mind this principle, parallel asymmetric processing. Where does this come from? This comes from safety. Just imagine traffic lights, and I think you don't want to have a green light on two ways simultaneously. It would be a very dangerous issue. So we use PLCs, you know, programmable logic controllers. And when you ask for safety, probably we'll ask first of all with, by two controllers working in parallel to be sure that if one controller fails, the other one will be safe. But there is one step further. This protects you against a hardware failure, but if you have a software failure, even if you have two processors, they will do the same mistake simultaneously. So the best in safety is having two different processors programmed in a different language by two different people. It's very unlikely that we do the same mistake. And that's very important in safety. This is really the upper level of safety. So here is parallel asymmetric processing in action. Okay? You need processor 1, which is software, which is strictly obeys to input and algorithm, no fantasy, no initiative, no awareness, damn fast, can handle tons of details, shall be programmed. Doesn't learn from experience. Not yet, don't know. With expert system, we will see in the future. And here you have processor 2, which is the brain. Evaluates input, which is very important. Has fantasy, initiative, can invent new solutions, should be aware. Damn slow in calculation, of course. Shall be trained. So if you are trained, if you are competent, you can use the software and you can be confident that the result is correct. Please remember, software is just a big procedure. Procedures do not replace expertise. Procedures may only help experts. This is very important. So professional software, of course, is needed. When selecting software, look about a lot of things. But here is the most important sentence. Be prepared and trained to understand what happens during the calculation. And training is the key to maximize the benefit of experience. If you are trained, if you understand, every work you do builds up as experience, you become an expert. If you're not trained, you're just going around and losing more or less your time, not knowing what you're doing. So it's really important, first the training and then going on, so that you can use a software. So my conclusion and summary is calculation tools are needed, and to support this, the design activities, setting legal requirements requires traceable and comprehensive methods. And then you need to apply this method with the software. EPB standards are designed for this objective. Professional software is the right level. It has to be used for productive use. A market is necessary. This is coming, probably. So Italy is the first example, but maybe some other country may go the same way. Software is a tool, and it has to be user-friendly and give feedback, but professional using software tools shall keep control of the calculation. So they need experience and training. Okay. And thank you. If you have questions.